Hello everyone. In this video, I'm going to talk about inner functions, also known as nested functions. As their name implies, they are simply functions that are defined within other functions. So what are they used for? One use for nested functions is to help with encapsulation, which in programming is the restriction of direct access to certain components of an object, like variables and functions. In this case, we are protecting a function from being called directly by defining it inside another function. So let's start with the first example, which will not only cover the basics of a nested function, but will also serve as an example of the encapsulation use case. In this example, the nested function is only called from within the function it is defined in. So here we have the main function. This is the one where, wherever it's accessible to, we would call this in order to actually execute the code inside it. And then this next line here is the definition for our nested function, the inner func. And it's just a simple print statement right here, but we can have more complicated stuff as we'll demonstrate further in the video. And in this basic example here, we're just basically defining the inner function, and then we call the inner function from the outer function. So all we have to do is just call the outer function, and it will take care of the rest. So if I run it, we'll see the message called from the inner function printed on the screen. We cannot call the inner function. If I try to call the inner func, it doesn't know what we're talking about. The only way to call the inner function is by calling the outer function, which is why nested functions are pretty good for encapsulation purposes. And it may look like we can do it this way because the Python linter is not saying anything about it. But if I were to run this, we would get an exception. So it wouldn't work that way. And while we're still covering the basics, let's also take a look at function parameters and return values for nested functions. Even though it's a nested function, it's pretty much the same as a regular function. You can feed in variables, you can have it return stuff. It can pretty much do everything that a regular function can do because it's still technically a regular function. It's simply defined in another function and therefore can only be used from within that function. So our inner function here takes two parameters, an x and a y, and it's going to return the addition of those two together. And then our outer function will call its inner function while passing in the values 2 and 4. So when we call outer and store the return result into x and print out x, the result we should see on screen is the number 6. So when I run this, there's 6. And the outer function is not restricted from taking in parameters as well. They can both take parameters, and sometimes the parameters of the outer can be passed into the inner if necessary. Another use case for nested functions is the Python decorator. Our decorator is basically syntactic sugar for deploying wrapper functions, and it requires a nested function to work. So I created a decorator function called decfunc, and it takes its minimum one argument that it requires, which is the argument for the function it's going to decorate. And then inside it has its nested function, which is the wrapper function. Decorator functions must have this layout. They must have a wrapper function defined under the decorator function, because if it doesn't, Python will give an error when you try to use this function as a decorator function. And the wrapper function is the part of the decorator that pretty much does the majority of the work, which includes executing the function that it's supposed to wrap. So in this case, our wrapper function is simply printing out some messages before and after the actual function call. And then at the end here, the decorator function will simply return the function object of the wrapper function. And to utilize a decorator function, we start with the @ symbol here, followed by the function name of the decorator function. And we put it over the function that we want it to decorate, which in this case is print message. So then all we have to do is call the print message function, and it will take care of all of this for us. So when I run this, we get the messages from the decorator function, followed by the message of the actual function, and then more messages from the decorator function. And real quick, I call this syntactic sugar. So what syntactic sugar is basically the ability to make something in a programming language that's designed to make certain things easier to read and to express, and otherwise pretty much execute. So what is a decorator function syntactic sugar for? Well, in Python, before we had decorators, and this was a long time ago because decorators came in a very early version of Python 2, we had to wrap functions like this. You may recognize this example from my other video, Python functions are objects. So in this case here, I have a regular function, and then I have a function wrapper. I call the function wrapper, passing in the function name of the first function into it. And then in here, we basically print out the same messages as before, followed by executing the function itself. So it's essentially like that, except it's a lot nicer because all we have to do is call the function that's going to be wrapped. The function decorator will handle all the wrapping for us, and will keep it nice and neat. But that's as far as I'll go into decorator functions for now. It's going to have its own dedicated video because there's so much more to cover with decorator functions. I just wanted to show you a basic decorator function as an example for nested functions. Returning function names is not limited to decorators. We can build nested functions that are meant to be returned in order to be executed outside of the function they were defined in. In this example here, we have an inner function that takes two parameters and it returns the multiplication value of those two numbers. The outer function will return the function name of the nested function. And down here, we will store that function name into this variable f. And then when we want to execute that inner function, we simply add a set of parentheses with the parameters required for the inner function at the end of the f variable and store the returning result into x. And then we will print out x. So when I run this, we should get a result of 30. See? And another way of handling this is, say if I add a parameter main number to the outer func, we'll get rid of x. So I can prime this with a number that will always be multiplied. And then for f, I would only have to define the second number. And just to show some other examples, let's say f3 or 4, that works too. And then f3. So we should get 20 from this one and 15 from that one. See? 30, 20, 15. Okay, now the last thing I'm going to talk about with nested functions is scope. And this is going to take a couple of examples to fully demonstrate. So for the first example, I'm simply going to show how anything that's accessible by the outer function is accessible to the wrapper function, which is something I kind of already demonstrated in the previous example. But in this case here, we've got the outer function upper or lower, which accepts a single parameter type. And type will either be lower or upper to say we want something in all lowercase or in all uppercase. Because what's going to happen is our wrapper function will take in a string and it will either convert the whole string to uppercase or to lowercase depending on what we set the type to. And it's going to return the function name of wrapper so that it will be executed here. So the first time we'll store it into the variable L for the lowercase conversion. And then the second time we'll store it into the variable U for the uppercase conversion. But as you can see here, even though this is a parameter for the outer function, it's still completely accessible to the inner function because we can print it out here and we can check it inside of a conditional statement to see if it's upper or lower. So when I run it, so from the upper and lower function, it prints out that type is set to lower. And then from the wrapper function, it confirms that the type is set to lower. And then it converts our all uppercase sentence here to lowercase. And then the same thing for upper. It confirms it in both the upper or lower function as well as the wrapper function that it's set to upper. And then it converts this lowercase sentence to all uppercase. So nested functions are fully capable of accessing variables and other things that are accessible to the function they are defined under. However, things get a little bit complicated when you try to have a nested function change the value of a variable that's from the outer function. So in this case here, the outer function has a parameter x. It's going to print out x before and after the function. And then under the inner function, we're going to modify the value of x and then print it out. So when I run this, we start with passing in 2 as x. So it's going to print out as 2 here. And then in here, we're changing x to 4. And then when we print it out here, it's going to say 4. But what do you think is going to happen with this line here? Is it going to be set to 4 or is it going to be set to 2? It's going to go back to 2 because when we set x to 4 in the nested function, we are creating a new version of an x variable. So this variable x is completely different from this variable x the moment we try to reassign it. So when I run this, as you can see, it's 2 at the beginning, which is right here. Then it's 4, which is this statement right here under the inner. And then it goes back to 2. And one thing I would like to demonstrate real quick. If we try to print x before modifying it, when Python runs the code through to convert it into the executable code, if it sees that at any point we try to redefine x inside this nested function, it's going to throw an error if we try to do anything with x before it's defined, because it's considering this as a completely different x variable that's being defined here. So it doesn't think we're trying to print out the version of x from the outer function. because the moment we tried to do an assignment, it became a completely different X. So when I run this, we get an error because we tried to reference a local variable before defining it. And just to further demonstrate that nested functions are basically like regular functions, it doesn't matter where you define a variable outside of its scope. As long as it's defined before it's called, it will be able to see it and reference it. So we've got a num equals 2 here, and above it, we define a nested function that will print out num. So even though num isn't set until after the function definition, the function will still be able to access it when it's called. As long as the variable is set before the actual function call, it'll still work. See, it prints out 2 just fine. For this final example in scope, I'm going to show you a new keyword, nonlocal. In the example where I took a variable from the outer function and attempted to modify it from the nested function, we saw that the change in the nested function did not carry over back to the outer function. In order to make a change like that from the nested function permanent in the outer function, we have to use nonlocal. Nonlocal labels a variable to tell Python that we are referencing a variable outside of its scope. So any changes we make and any assignments we make should be done to the variable that we are referencing outside of this function. So in this example here, I've got a function called submit name, and it takes in a full name, first and last. We call the split function here so we can split it up into first and last names. And after we extract the first and last name from the full name, we call the function check casing. Check casing will use nonlocal on the first and last variables. So we're telling it to reference these two variables right here instead of attempting to create first and last variables local to this function. Then we reassign the first and last variables with the return result of correct casing, which is up here. Correct casing takes in a single parameter, and that's a name. It's going to force the first letter of the name to be uppercase, and then it's going to force all letters after the first letter to be lowercase. And then it's going to return the modified name as a result, which will then get stored back into these variables here. And then submit name will return the newly modified first and last variables as a new full name. So that's what nonlocal is for. If you ever want to reference and modify a variable that is external to the nested function, then make sure you use nonlocal if you're not going to pass it in as a parameter or return the value back. And for our example here, we've got Beth Anderson, and as you can see, the first letters of both her first and last name are lowercase, and we got a bunch of uppercase letters that should be lowercase. So when I run this, it prints out Beth Anderson with proper casing. And that's about it for nested functions. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.